Hey guys, my name is Michael Spano, and I'm interested in the interface between electronics and chemistry. Let me tell you a little bit about the flow chemistry apparatus I built around open source microcontrollers and using a 3D printer. I built this system to study the competition that happens between the clarke-eschweiler and pictet-spengler reactions. I'm interested in automating the task of probing for optimal reaction conditions. The reactor is simply a steel tube recovered from a gas chromatograph. I use 2-piece ferrules and 1/4-inch nuts to make fluidic connections. This T-mixer is placed right before the reactor and serves to mix the reagents. I use plastic tubing to feed the chemicals into the T-mixer. I use plastic because it is much more flexible and won't be in the high-temperature oil bath. These transparent lure adapters are great for joining the tubing to syringes. This way, the syringe pumps can be far apart from the reactor. You can find the fittings that I use in this video from IDEX Health and Science. These parts are a really big help when building your flow chemistry system, and I highly recommend using them. It is possible to run these reactions at temperatures higher than the standard boiling points by using a pressure regulator, like this one. At the heart of this flow system is an Arduino Uno compatible microcontroller. I use a 3-axis CNC shield for this particular project. You can find instructions on how to make the electrical connections for a similar system at the link on the screen. Alright, let's take a look at the Ghostoik version of the code. This code is used to control 3 syringe pumps, being that 2 are for reagents and 1 is for an inert solvent. Just a reminder, you can get more details on how to build this system on our research group website. If you have trouble, you can email me personally at brzUSA@gmail.com. Alright, upload the code to your microcontroller, and with it still connected, open the serial monitor by going to Tools, then Serial Monitor, or by pressing Ctrl-Shift-M. Select a baud rate of 9600 and enable New Line and Carriage Return. You should be prompted by a splash screen along with relevant variables and their default values. As the user, you can control the program by typing commands using the following syntax. The command comes first in lowercase and is always followed by a closed bracket. Then if the command you are using requires a number, the number comes next, followed by another closed bracket. An example is the diameter command, which informs the microcontroller what diameter syringes you are using. An example of the proper syntax is like this. This code is currently set up for conducting sequential plug flow reactions. Specifically, the 2 reagent pumps, number 1 and number 2, are initiated simultaneously. Once the plug volume is achieved, the reagent pumps are turned off and the solvent pump pushes the plug through the reactor. Now let's take a look at the commands and the variables that they control. Reactor volume holds the total volume of the reactor in microliters. This is also the volume that the flush pump, or the solvent pump, will dispense after the plug. Plug volume holds the volume of the plug. Diameter changes the internal diameter of the syringe, allowing you to use different size syringes. Lead changes the thread density of the lead screw. This allows you more flexibility when building the pumps. You can use metric or imperial. It doesn't matter so long as you inform the microcontroller. Stoich is a variable that requires 2 numeric inputs, separated by a colon mark. These numbers control the relative flow rates of the pumps, and do not necessarily control stoichiometry unless equimolar solutions are prepared. Then it does. Time is the desired reaction time in seconds. Set 1, set 2, and set flush are used to inform the volume that is currently in the syringe. Volumes is a non-numerical command and it returns the volume in each syringe. Snug, followed by 1, 2, or 3 after the first bracket, is used to move pump 1, pump 2, or the flush pump forwards, independent of each other. This is used to adjust the position of each pump before initiating an experiment. Analogously, slip is used to move the respective pump backwards. Let me show you how a typical experiment is conducted. Open the serial monitor, and after the splash screen is displayed, you can fill the syringes with reagents and use the snug command to adjust the slack in the syringe pumps. Typing in 0 and pressing enter will stop any active command. Using the volumes command, you can see that now the microcontroller thinks there is a negative volume in the syringes. Let's correct that by using the reset command. Use volumes to verify that volumes has been reset to 0. Alternatively, you can proceed to inform the correct volume of the reagents in the syringes by using the set commands. Let's assume in this experiment that all 3 syringes are filled to the 5 milliliter mark. The next step is to set the relative rates of the reagents using stoich. In this case, I'll use a 1 to 2.2 ratio. Don't forget to use a colon mark between the numbers. The default reaction time is 1 minute. Let's change that to 30 seconds using the time command. Now we can start the experiment by passing the go command to the microcontroller. You can see when the experiment is initiated and the reagents are being injected. This continues until the plug volume is achieved. Once that is done, the reagent pumps stop, and the flush pump takes over by pushing the plug through the reactor at the correct flow rate to maintain the reaction time. Once the plug exits the reactor, you are prompted to set new reaction parameters. If you don't have sufficient fluid in the syringes to proceed with a new experiment, like so, the microcontroller will warn you. This is to avoid starting an experiment only to have the plug get stuck in the reactor. And it's as simple as that. Thanks for sticking around to the end of this video, and if you need any help replicating steps in this sequence, just feel free to contact me, and I hope that you can build a system just like this one and it can help you in your chemistry needs.